Okay, today we're going to talk about one of the math calculations that we're going to do in the solutions chapter. And what it is it's called molarity, the concentration of a solution. We abbreviate molarity with a capital M, and what it stands for is moles of the solute over liters of solution. Make sure you realize that it's the solute, and we're talking about liters of the entire solution, not just the solvent. So, in this part of molarities, you're going to look at three different problems. The first one, you're going to calculate the molarity. The second type of problem that you could run into is calculating the volume of that particular solution. And the third is calculating either the mass or the moles of the solute. So, if you remember back in the density chapter, we talked about, we had this little triangle, and instead we had density, and in this case, we're going to have a capital M for the molarity, moles at the top, liters down at the bottom. And remember, it's basically, you cover up whatever you're trying to find. For example, in this first one, we're looking for the molarity. So we would cover up molarity, and we'd have moles divided by liters. In the second one, we're looking for volume, and that's measured in liters. So we cover that up, and we have moles divided by the molarity. And in our third example, calculate the mass or moles. Well, you're always going to have to solve for moles first. So we're going to cover that up, and it's molarity times liters. And what I like to do is I like to sometimes say grams can either go into moles, or we can find moles and go out to grams based on what we're looking for. So I put over here, you're going to have to convert from grams to moles, or in some cases you're going to have to convert from moles to grams. So let's look at three different types of problems. The first one, calculating molarity. So here's our problem. What is the molarity, because it's a capital M, of a solution that contains 210 grams of aluminum sulfate in 2.75 liters of solution? So we're looking for the molarity of the solution. So if I use our triangle, I cover up molarity, and it's basically molarity, that's what we're looking for, equals the moles over liters. Well, in this case, we don't have moles. We're starting with grams. You're usually not going to have moles to start with because we don't have bags or boxes of a chemical in moles. Instead, we have it in grams. So we first have to convert from grams into moles. And we know how to do that. We would take 210 grams of the Al2SO43, and we're going to use, just like we've been doing dimensional analysis, finding the molar mass of Al2SO43 on the periodic table. This is already done. 342.3 grams is 1 mole of it. And again, you can look up each mass on the periodic table, add up the total mass, and that's what you're going to get. So if we put that into the calculator, 210 divided by 342, which I've already done, you're going to get 0.613 moles. So now we have moles, we have liters, and we just put it into our formula. 0.613 moles divided by, given to us in the problem, 2.75 liters. Divide, and we get 0.223 molar. And this is going to be our final answer. You can put Al2SO43 if you want. That's actually the solution that you made. But we found the molarity of it. Okay, let's look at the second problem. In this case, it says what volume. So right off the bat, we know that we're looking for liters, because that's volume. We can use our triangle again. I make a small triangle right here. Molarity, moles over liters. So we're looking for this right here. So we know we will be doing moles divided by molarity. Well, we have molarity right here, but we don't have moles. So we're going to have to convert from our grams into moles, just like we did before. So we have 60.0 grams NaOH. Use the periodic table again. Add this up, 23 plus the 16 plus the 1 gives us 40.0 grams. NaOH is 1 mole of NaOH. Remember, we're going to cancel out our units. That's how we get moles by itself. 60 times 1 divided by 40 is going to give us 1.5 moles. Now we have moles, which this is our formula. We have the molarity. Put it on the bottom, 1.25 molar. And if we rewrite that, that's moles over liters. And our units are going to cancel out here. So put this into the calculator, and we get 1.20 liters. And this is our final answer. That's what we are looking for, the volume of it. So that's the second type of problem that you can have. Let's look at the third one. The third one, what mass? I think the hardest part of these questions is trying to figure out what they're asking for. So read the question carefully, look at your given information, and then look at what you're trying to find. So what mass of NaOH is needed to prepare 3.00 liters of 0.250 molar solution? So again, look at your triangle, molarity, moles, and liters. Well, we're looking for mass, so we're going to solve for moles and then convert to grams. So we have molarity times liters. Well, the molarity given to us, 0.250 molar times 3.00 liters. Remember, this is moles over liters, so our liters are canceling out. Put that. Multiply it out, we get 0.75 moles of NaOH. And now we're going to convert from moles to grams. Same way, 1 mole on the bottom, NaOH, 40.0 grams, 0, of NaOH. Moles is going to cancel, multiply, and we get 30.0 grams of NaOH as our final answer. So 3 different types of problems. Make sure you know what you're trying to solve for. It won't always be written as what is, but in the problem, figure out, are you solving for moles, molarity, or the volume?